Okay, number 43, we're actually doing two different parts of two different parts. So in part A, you have a rod, a stick, that is rotating around the 50 centimeter mark. Okay, so it's going to rotate around like this, and on one end you're going to have your mass. And so what you're going to do is you're actually going to have to deal with this as two different pieces. Okay, we're going to deal with the first. We have to find the angular momentum of the piece, so this one right here. And how we're going to do that, we're going to deal with that as a hoop, or as something where the mass is all on the outside. So if we just do I times omega, what we do is we take the, since this is all that hoop, this I is going to be mr squared, and then we'll just multiply that by the angular velocity. Now the mass they give us is 0.4 kilograms. The distance from the center, from the point of rotation, is going to be 0.5 meters, because that's the distance away. Since it's on a meter stick and it's a 50 centimeter mark, we know that radius has to be 0.5 meters. But don't forget to square it. And then they also tell us that the angular velocity is 4 radians per second. And so when I get that, put that all together, I end up getting 0.4 kilogram meters squared over seconds. So that's my angular momentum of that piece. Now I also need to find the angular momentum of my stick. Okay, the stick, when I do that, that's still going to be I omega, but because it's rotating about the center point, it has a special moment of inertia, which again, if you went and looked in the notes or whatever, you would find that that would be equal to 1/12 ml squared. Again, this is one that I will tell you, or I will give it to you if you ever need it during a test or something like that. So this would be 1/12 ml squared, where L is the entire length of the whole thing, okay, times the omega. So I'm going to go 1/12 of the mass, which they told me was 0.1 kilograms, and then I would multiply that by the length, which I know is 1 meter because it's a full meter stick, don't forget to square it, times my angular velocity, which is 4 radians per second. And when I calculate that out, I end up getting 0.03. So 0.03, and I put the decimal in the wrong spot. I apologize about that. There we go. Okay, so then when I add these two together, and I'll put this in red for color coordination, I end up getting 0.43 as my total angular momentum of the system. Now, for part B, I'll put this back in black. Now my system changes, so now my rod is out here. My piece is still sitting on the end, but now I'm going to rotate around this point, around here. So we end up having to change our moments of inertia for both things. So I'm still going to use the same equation, that L is equal to I times omega, and that's going to be equal to, since we're talking about the piece first in here, so we'll call this L piece and then L stick. Let me do the same thing down here, so L piece. Okay, I'm going to take the moment of inertia of the piece, that's still going to be mr squared, and we're going to multiply that by omega. My mass is still going to be the 0.4 kilograms. But now my distance away from the pivot point becomes 1 meter. Don't forget to square it, times omega, which was 4 radians per second. And so when I multiply that together, I get 1.6 kilograms square meters per second. Now I have to find the moment of inertia of the stick, because it's now changed. So now the whole thing is rotating. Oops, wrong way. The whole thing is rotating around that pivot point. Now the moment of inertia changes to, in this case, its moment of inertia is going to equal 1/3 ml squared. And again, like I said, I will give you those. You won't have to memorize them. So we go 1/3 of ml squared times the omega. And so 1/3 of my mass, which we said was 0.1 kilograms, the length is still going to be 1 meter, don't forget to square it, times the omega, which is 4 radians per second. And when we multiply that out, we end up getting 0.13 kilogram meters squared per second. So now when we add these two together, our L total kicks out to be 1.73 kilogram meters squared over seconds. So answer number 1, answer number 2.